Great. Yeah. Okay. So good morning, everyone. My name is Gougoulou, and currently I'm a senior data scientist at SEBx. But first, I would like to introduce myself for those of you that attend this meeting today. So I'm originally from Greece. I have a background in computer science. And then I moved to Stockholm in Sweden to do my master in machine learning and then PhD in machine learning and language modeling. Before joining SEBx and SEB, I was part of RISE Computer Science, more specifically working with AI, and did my PhD in training large language models. Many of you might have heard about GPT-3, the first Scandinavian large language model. But now this journey is over, and since June I started at SEBx. So a little bit about SEBx, because I don't know if many of you have heard about us. So basically we're the innovation studio of SEB, and our goal is to shape the future of finance for the next 150 years. It's quite a big goal and very exciting. And we do that by trying to predict shifts and implications in the market and in the outside world. And we do that with curiosity and world-class technological expertise. So we're a team of 16, around 16 or 17 people. We have quite many people with academic background, PhD background in computer science. And then, as you see here in this image, we're sort of the bridge between the bank and the different divisions in the bank, and then also the external network. So we have a collaboration with academia, big tech, fintech, other industrial networks, etc. So yeah, this is a bit about SEBx. So now it's time to move on to the sort of the technical part of this presentation. And the first topic I would like to cover is, of course, about agentic AI, as it is the hot topic these days, and many of us, also us at SEBx, are interested about that. But let's start with sort of the basics. So what is an agentic system? So at least in our view, the agentic system is basically more than just an augmented LLM. So in the LLM, when you augment it, instead of just doing text prediction, you also add some tools and reasoning loops. So instead of just having a passive assistant that just answers some questions, it also acts more like a problem-solving agent by, for example, being able to retrieve information from your database or documents, etc. But now, when you have the agentic system, you augment this thing even more, and instead of just having access to conversation and data through retrieval, you also give it the ability to have actions. So basically, the agentic system is able to bridge static knowledge with dynamic real-world information. And here to the left, you can see sort of a very classic picture of that, which is taken from the Anthropic blog. If some of you have heard about it, I would really recommend it. So another important component here, which I did not mention, of course, is memory, because where you have the agentic system sort of communicating or sort of serving the human in this discussion, you also want to have this memory in the session, so that the next time you're going to have an interaction, you're going to pick up the history, the conversation history, the user preferences, for example, where you ask the system to generate a report, etc. But then, of course, the next question that comes to mind is, how does this matter to a bank at SEB? And of course, to a first level, it is a tool that helps us to boost productivity for all of the experts in the bank, both financial experts, but also developers. And it is able to help us to reduce repetitive manual work, like taking notes, summarizing documents, going through long documents, etc. But then this is just the first level, because on the second level, agentic AI can also empower decision-making and providing a personalized experience. And this talks to more sort of to more like the core decisions and the core functionalities we have in the bank when it comes to, for example, like predicting cash flows, when it comes to helping experts maybe go through documents in a faster way and getting important signal early in the process of auditing, etc. So with this, we're able to basically enhance qualitative insights by augmenting like augmenting predictive analytics. So for us at SEBx, we have currently a moonshot idea of how we would build such sort of like an idea of an AI-powered financial advisor. So in this case, as you see in this picture, we have as input different kinds of data sources, and want to use sort of agentic AI in order to be able to combine those in the best way that serves the user. So we have account statements, we have market data, we have financial reports, for example, the yearly reports from companies, and then also we have media and news data as sort of the global outlook from the market. And then we want to use this data in order to be able to predict cash flow, to analyze the market trends, even to simulate different scenarios and try to answer all of these what-if questions that come to mind. And of course, the goal of that is to provide proactive risk management and then also provide better advisory. And a key technology in all of this, apart from the predictive part of it, which comes to more machine learning models, etc., and time series models, which I will cover a bit later. A key technology in this moonshot goal is how we're going to interface the machine learning models with the user. And we think that a key technology here is agentic AI and deep research. So a little bit about deep research, which is a specific agentic application. And the goal here is that this application is able to guide the LLM through a multi-step process in order to solve a complex problem. For example, doing a credit analysis for a specific client or something similar. And the key component here is that first we want to break down the problem into research plan and clear logical steps, and then the system has access to web search and document retrieval, with a goal to retrieve relevant information that is going to fulfill this research goal and those steps. And then also, as part of the process, the system can also incorporate human feedback to adjust the research goal and the research findings. And then in the end, all of these research findings are being compiled into a report that is being presented to the user, and even having the ability to edit the report, given the memory feature that we discussed earlier. So going a bit deeper on this, this is how we currently think about the deep research architecture, and I will go through this figure here. I just want to say that we're currently sort of like from technical perspective, we're looking a lot into the ADK, the Agent Development Kit, which is an open source library from Google that allows you to easily build customized agentic flows. And here we see a current prototype of a deep research system. So we have the user providing a prompt. For example, I want to have a global outlook report for a specific client. And then in this case, you have the interactive planner agent that tries to first gather information to create this plan. And we have a tool that is able to fetch information about the company. And then also having access to another sub-agent that is able to do web search queries to find more information about the specific user request. And then given that, we then have the plan generator that generates this research plan. And here the user can also decide whether they want some changes, whether they want some additional goals, maybe additional sections in this report, etc. And after that, we have the section planner that is able to decide on an outline for this report. And after that, we have one of the main components of the system, which is the section researcher, that actually does the research and sort of the compilation of material for each of those sections. And for this part, we have two main tools to use to do this research. First of all, we have access to company information that is available in the context. But then also we have access to a RAG tool that basically sits on a set of financial reports or documents that the user can provide in this session, etc. And after this first pass of research is completed, then we have this refinement loop, where we have an LLM as a judge, a research evaluator, which in this case has a critical eye on the current state of the report. And in case that it fails, which often happens in the first iterations of this, then it also has access to an additional agent that can do web search and fetch more information to improve the quality of the report. And then in the end, we have a report composer, which compiles the report and even has access to visualization tool to create graphs, etc., given the research findings. And that is the final output that we provide to the user. And of course, this is sort of a first iteration of this. And as I mentioned before, we think of Agentic AI as the interface between the human and the predictive modeling that sits in the backend. So one could also imagine that here, as part of the section researcher, we could also have access to forecasting models to predict, for example, company cash flows or any other type of predictive modeling we can think of, depending on the use case. But of course, there are some technical considerations that we think and also motivate sort of other people to think when designing agentic systems. And one is that still rich data is king. Even though the system might have access to tons of different data sources, it still needs some guidance to when to use each of the data sources. And we think that it's very important to curate the right data context for the agentic system by for example, try to format the data in the right way, providing additional schemas for databases, etc. So that we try to guide the system into choosing which data source, which data point is more relevant to the specific user query. And then it's also important to have human in the loop, not only to catch unexpected system behavior, which often happens when you use LLMs and agentic systems, but then also to be able to enable but also to enable user edits on the fly. As mentioned before, a big feature of the agentic system is the memory. So this allows to have this constant memory in the system that's being updated as the user interacts with the system, and then allows this instant or like on the fly edit of the report or the output of the agentic system. But then at the same time, there is also an important balance to think about versus, so have a balance between autonomy and audit, because if you just over-rely on human feedback and sort of ask for confirmation at every step in the system, then in a way it's also a way to defeat basically the purpose of an agent, which is to have some level of autonomy. But one, I think, here needs to strike the balance based on the use case. But in any case, it's very important to have human in the loop in the agentic AI system, at least at one point in the flow. And then now we have covered the agentic AI. Now we'll talk a bit about the second part, which is time series modeling. So when it comes to the backend ML predictive models and how we think about them at the SEBx. And of course, time series is a big part of the bank, and we have a lot of time series data, from yield curves to stock price curves to different types of time series data. And of course, the first thing that comes to mind when it talks about time series and what can a time series model do is basically forecasting, which means to fill in missing data in the tail end of a time series, as we see here with the red dots. But then we want to think of these time series models and take them one step further. So one can also try to condition this forecasting based on additional information. And in this case, you can see that basically the forecast might change based on the market condition. In this case, market condition can be an additional text or other type of signal from, for example, from global news, or maybe combining that with some other type of information. And in this case, having the condition of the market being bear or bull, then we can see that the forecast really changes in the time series. But then, apart from the task of conditioning, we also have the other very useful task, which is denoising, as sort of like the real time series data using real data tend to be quite noisy. So being able to denoise and remove this extra information can really improve the prediction quality if one wants to use the time series signal as an input to a classification model in the future. So here you can see really the difference between the original stock price, quite noisy signal, and the denoised stock price in blue. And one approach here on how we would like to train this type of time series model is diffusion. And some of you might have heard diffusion before, especially in the image domain. So have one slide about that, sort of to cover a little bit of the basics. So the denoising diffusion models, basically we have the process of forward diffusion, where we start from a clear image, and then we continuously add noise until we reach a static random image. But then the idea is to train the denoising diffusion model to basically do the reverse process. So to start from a completely noisy image and progressively make it into clear image. And one can think that this is a quite important task when you have time series data that's quite noisy. And people indeed have tried to copy this training process for time series, as currently this process is quite widespread in the area of computer vision. So when it comes to trying to do diffusion for financial time series, there are already some actors in the domain that have tried that, like MasterCard and JP Morgan, where they have tried to denoise time series, for example, to improve the trading signal accuracy, or maybe to be able to provide a better measure of forecast uncertainty, or even do synthetic data generation, which is also quite important aspect here, as the time series dataset can have a quite big variation, even comparing to text data. But then one can also take it one step further and basically combine time series with text. As I mentioned before, text can be a quite important condition signal here when you want to do forecasting. And this can be text signal from the news, maybe some sort of sentiment from the market, etc. And we're kind of looking into ways on how to train this forecaster in a multimodal way. So basically combining text data with time series data, and being able to do a forecast based on the combined embedding of the time series and the text. But of course, one of the main challenges here, as sort of which is common with any type of machine learning model, I would say, is the training data. And one aspect is that financial signal is quite noisy and the quality is low. But then also, if one wants to combine documents and time series, the alignment does not come easy. One needs to annotate and filter and curate the data so that you have a good alignment between the text and the time series. If you want to use sort of the best signal possible here. But at the same time, it's important to think about the cost of collecting, curating, and annotating high-quality training data. And then I have a couple of last slides about a specific use case of like time series forecasting, specifically yield curve forecasting. And this is a project that my colleagues have done. So here, what we have basically tried is to have a multivariate time series forecasting model using a data-driven method based on neural networks, and the goal is to estimate the yield curve for mortgage bond in each day. And then after doing that, the next step is to be able to use temporal information to predict the evolution and the curvature of the yield curve for the next n days. And here you can see one visualization of this multivariate time series, where you have the time, you have the maturity months, and then you have also the yield. You also have the yield value here. And basically in this figure we see we have a time span between May 2000 to May 2020, and we have maturities from 3 to 120 months. And I would also like to mention that this is a work that's done in collaboration with financial experts from the bank, and we also have a paper from my colleagues that has been accepted to ECAIF 2025 to work up there. And this is just sort of a first approach to try to do yield curve like forecasting in a more data-driven way by using sort of simpler neural networks. And there are some more ideas to try to see how we can improve that by using some more sophisticated machine learning models. So yes, thank you very much.